Bismillahirrahmanirrahim. Today we are going to speak about the vector valued function. Last time we spoke about the vectors and we gave the dot product, cross product and their properties. For today we are going to speak about the vector valued function. Start by the definition of the vector valued function. Before we said that A is a vector consists of some components A1, A2, A3. And these components A1, A2, A3 are constants. If the components are not constant, if they are function, then we have something called the vector valued function. So the vector valued function, okay, this is A1, A2, and A3 are constant. This is constant vector. The vector valued function is a vector where all the components are function of some variable t. For example, f of t, g of t, and h of t. Or in the other notation, we can write it as f of t I plus h of t k. So this is the vector valued function. And since we are speaking about the function, we will discuss the limit, continuity, and derivative of the vector valued function. Start with the limit. For the limit of a vector function, we need to check the limit of the component of the vector function. So we say that if limit of f of t as t goes to a, and limit of g of t, and limit of h of t. Now, if the three limits, limit f of t, limit of g of t, limit of h of t as t goes to a exist, then limit of the vector function equal to limit of t, limit g of t, and limit as t goes to a. find the limit for a vector value function, it means that we have to find the limit for all the components of the vector function. If they are exist, then the limit of the vector function exists. Say, for example, find the limit of the vector function. Given that R of t equal to given the vector function R of t equal to 2t square cosine t and tangent of t, and we need to find the limit of the vector function R of t as t goes to 0. That means that we need to find the limit for each component of the vector function. So the limit t goes to 0 equal to limit of the first one as t goes to 0 will give me 0. Or let's find them one by one. Limit of 2 t squared as t goes to 0 is equal to 0. Second one, limit of cosine of t as t goes to 0 is equal to 1. And limit tangent of t as t goes to 0 is equal to 1 or 0, 0. Sorry. The limit of the tangent t as t goes to 0 is equal to 0. This means limit of the vector function as t goes to 0 is equal to 0, 1, and 0. So the limit of this function will be equal to 0. Another example. See. Given R of t is equal to 3 divided by t square plus ln of t divided by t square minus 1 j plus cosine of t. And we need to find the limit of the function as t equals to 1. Let's do it. We need to find the limit of this vector function, 3 divided by t squared, ln of t divided by t squared minus 1 plus cosine of t. So let's find the limit for each one of the component. Component A, the first one. Limit of 3 t squared as t equals to 1. Replace t by 1. We will have 3 over 1, which is equal to 3. So the limit of the first component is equal to 3. Let's find the limit for the second one. Second component. Limit of divided by t squared minus 1 as t goes to 1. Now if we replace t by 1, it will be 0 up, and t also by 1 down, it will be 0. So this is 0 over 0. I'll get 0 over 0 if we replace t, or if we substitute t by 1. And if it is 0 over 0, this is a special case where we need to use something called the L'Hopital rule. So using the L'Hopital rule, so that the limit of a function, if it is 0 over 0, equal to the limit of the derivative of the first. So this will be equal to the limit. Okay, let me state this one. Limit of f of t divided by g of t. If it is equal to 0 over 0, equal to limit the derivative given that so the L'Hopital rule said that the limit of a fractional or rational function equal to the limit of the derivative of the numerator divided by the derivative of the denominator if the limit of the numerator equal to 0 and limit of the denominator equal to 0. Also, if f and d are differentiable. So in this case, I got 0 over 0. So by applying the L'Hopital rule, we need to find the derivative of the numerator and denominator. So this is equal to limit as t goes to 1, derivative of ln of t equal to 1 over t. This is the derivative of the numerator only. Derivative of the denominator is 2t. Now replace t by 1, I will get 1 over 2. So the derivative for the second component is 1 over 2. First one was 3. Second component is 1 over 2. Now we need to find the limit for the third component, c. This is equal to cosine of 1. So this is the third limit. Now write everything together. This will give me limit of the vector function r of t as t goes to 1 is equal to, the first one gave me 3. Second one, 1/2, and third one is cosine of 1. And this is the limit of the vector valued function. So this is the limit of the vector valued function. The idea is to find the limit for each one of the components. If they are exist, then the limit of the vector function exists. Let's state the properties of limits. One, if limit of R1 with that we have two vector functions, and their limits are given by L1 and L2. Then number one, limit of C times R1 of T as T goes to A equal to C multiplied by L1, where C is scalar. Number two, the sum of the, or the limit of the sum equal to the sum of the two limits. Same thing for the negative also. The limit of the sum of the two vector functions equal to the sum of their limits. Third one, limit of their multiplication or their dot product. Equal the dot product of their limits. So these are the properties of limits of two vector functions. Example will be given in the coming part, but mainly this is the main properties for the logarithm or for the limit of two vector functions. If we have two vector functions, then the sum or the limit of their sum equal to the sum of their limits. If we multiply the vector function by scalar, then the limit will be the scalar c or constant c multiplied by L1, and the limit of the product equal to the product of the limit or dot product of the limit.